Welcome, Sean, to the Lunar Development Conference. Sean's the CEO of Masten Space Systems, and we're really thrilled that you're here to give a keynote on the CLIPS mission and anything else you'd like to talk about. I'll be back for Q&A, and yeah, we're just welcome to the conference. We're excited to have you.
Thanks. And Michael, I didn't catch the very beginning of your discussion, but in case you don't already know the connection, Michael started this journey of, this overnight success, what, decade and a half ago?
Yeah, decade and a half ago, an overnight that lasted 15 years.
Yeah. So in case you don't already know, it is always a small world. So very appreciative to all the work that Mike and the team did back in the Lunar Lander Challenge days to have there to be something for us to keep working on. It only took a decade between the Lunar Lander Challenge and then the next time that there was actual lunar money.
Yes.
So yeah, it's
that was part of my point. One of the things I made before, I think, before you came on, which is figuring out how to stay alive long enough for the market to come around to where you're at is a key to success. And it's patience, it's patient money, and it's patient customers. So yeah.
Yeah.
Good job. You took the ball and run further with it than any of us expected.
Hey, it's, we still got to figure out if I can get it all the way across the finish line, but we're working on it. So I appreciate it. And I know we've got about an hour here to discuss things. The main, I guess, the topic as it's listed in the agenda is to talk about the NASA payloads that are going and some of the kind of what Masten is doing in the lunar ecosystem. I am happy to talk about the development opportunities and where I see the opportunities both for Masten and for the rest of the industry, and what I think some of the key things are going to be the elements of success in the cislunar space. But I also am happy to talk more about some of the strategy that we have used over the years and be able to fit in some additional pieces for folks so they have some idea about maybe some things that might be able to be taken from what we've done and apply it to your venture. And I know a number of the folks that are on in the meeting, but there's also a lot of folks that I don't know. So feel free to drop things in questions and anything else along those lines. So let me just.
Yeah, I think that what you're talking about is great. And I think as my keynote was kind of alluded to, the applications and giving everyone on the call an idea of what it took and what it takes for you to get where you're at. Because very often in our industry, we do a poor job of letting people peek behind the curtain and just to see how hard these things are and what it takes. But yeah, the applications and where are we going is just as compelling. So I'm going to mute myself and stop my video and let you have the floor. So have fun.
Great, thank you. And please chime into the chat or questions as we go. So in case this is the first time you've heard of Masten or first time we've met, Masten Space Systems is delivering a set of payloads to the lunar surface scheduled for December of 2022, a South Pole landing. As alluded to, we've been working at this as a company for 16 years now. And how did we find ourselves at a place where we're actually delivering these payloads? And the answer is there's a paying customer, a paying anchor customer in the NASA CLIPS program. And so the delivery piece of actually executing on it is largely dependent upon the existence of an actual market, which is kind of new, even if it is somewhat nascent. So why were we awarded this and where did we come from? The company has focused on propulsive landing for most of its history. The couple of key parts in the history of the company: winning the NASA Centennial, Northrop Grumman Lunar Lander Challenge sponsored by X Prize, or sponsored, whatever. Yeah, I got all the names in there. Masten was a team, and I sat next to Michael in a bar here in Atlanta and watched the Masten team compete for that, and compete for it and win. $1 million is great, but $1 million doesn't get you that far when you're, well, in pretty much any business, but especially in the space business. So it was about a year after that when I got involved. And then over the intervening 10 years, while there was attention to some lunar delivery, especially in the GLXP, the fact of the matter is we couldn't get the business case to close with what was in the GLXP. We supported teams that were working on it. We were involved in all sorts of different discussions, but we could never get a business case to close for the actual attempt at delivery. So what we did instead was we focused on the customers, the people who we saw as most likely to actually have money and a reason to go to the moon, work with them, establish our credibility, establish that Masten is a credible partner, and understand those customers, understand what's important to them, understand how they go about making decisions, understand what are the influences that might be coming down from above. And the way that we did that over the 10 years is in two areas. One, the terrestrial test bed, flying vehicles like the one in the picture behind me, doing lower level demonstrations, but doing them frequently. We have over 600 operations with a free flying rocket powered vehicle. Haven't gone as high as others, but we have done more variations on landing, because going up is easy, coming down is even easier. It's sticking the landing that's the really hard part. So that's been our approach. That is then supported by the second one, which is lunar technology development. And that is, you'll see that show up in different supporting technologies that might be funded through an SBIR program, maybe through, we had part of the Artemis human lander solicitation. There's a bunch of other pieces where we've been able to get focused verticals with funded research, and that has been important. So those two have really driven the company. And I'll say, I wish I could say it would have been entirely off of revenue since the Lunar Lander Challenge. That is not entirely the case. We still have had investment that has come into the business, but it's been more in the angel, super angel side of things than in the large VC side. If you're thinking, hey, wait, weren't you guys also doing something in launch and all the rest of that? Yes, we were. Yes, we did. It was great. And that market got saturated with enthusiasm that I could no longer make the business case close. So just in case you're wondering, hey, whatever happened to reusable medium class launch? Too many enthusiasts for me to be able to keep that business line afloat. We did it for a while, and at the moment, too much competition there. So we'll leave launch aside. So now we have the flagship of delivery to the moon. And then we have also some outside crazy ideas that we're still working on. So the idea here is take technology development, testing, delivery, and then what are the services that are going to be enabled by that chain, which is the fourth piece in that. Now, I don't entirely know what that is. Part of the reason why I'm here now is talking to you, because we want to figure out where we can take our experience, our skills, our access and leverage that to turn into something else. Personally, the example is, because you work in the industry, you have an opportunity to see things that people sitting on the couch don't see. So being in the arena is how you get the opportunity to understand, okay, here's the real drivers and the cost. Here's the real pain points. Here are the things where commonly held that, I don't know, the internet doesn't have enough bandwidth to stream videos. And I know that might sound crazy, but in a previous career, that was the commonly held belief when I was working in data centers and internet connectivity. And turns out you could see the trends. And some friends of mine even started a YouTube competitor by being inside it, seeing the trends, understanding the way that things work. So that's what we're trying to do here at Masten as well. So that's kind of the broad overview of kind of where Masten fits into this lunar and cislunar world. I'll turn to the question of what is this NASA Eclipse in 19C. The Eclipse program is a NASA program funded under the Science Mission Directorate to do non-human delivery to the surface of the moon. The idea behind it is, as the administrator had said, shots on goal. It's a completely different acquisition model than what perhaps we are familiar with. They've really done their homework and have come up with a way. Now, it might be good and it might have some areas for improvement, but it's a different approach, and it basically says they want to buy space available, and it's up to the companies to make it happen. On one hand, it is very much like delivery of supply to the ISS. This is delivery of supplies to the lunar surface. In other ways, it's dramatically different. The delivery of things to low Earth orbit and delivery of things to the ISS there's been more to it. There's a lot more maturity there than perhaps there is to the actual lunar surface. So, you know, this program is still in its infancy. I have highlighted some of the things that I'm concerned about as the business person looking at this and trying to make sure that the pieces are there for a sustainable lunar access program. That's one of the objectives of the program. I've been somewhat vocal in saying, hey, there's these holes. But the fact that we are right now talking about doing delivery and we're complaining about the edges is phenomenal. Because for a very long time, it has been, well, when are we going to get back to the moon? When are we going to get back to the moon? When are we going to get back to the... Yep. That argument, I won't say it's completely resolved, but it is resolved now in that there are 3 companies that are already on contract. There are 4 missions that are scheduled. There are more to come, and some of those are going to work. I'd like to tell you guaranteed that Masten is. I can't tell you guaranteed that Masten is, because that's not the way this program is run. This is not a guaranteed of delivery. This is a give us an idea of what you think you can do, and we'll fund it as long as you keep meeting the plans that you put forward in your proposal. We'll keep funding it. So it is a very different kind of approach. So that's what the CLIPS program is. And I just want to make sure, if you're following, and I don't know if there's other members of the CLIPS vendor community that are in this conversation, there are some holes. But then again, it's kind of a new thing, and it is exactly the the sort of approach that we have at the high level said, we want to have commercial access. We want to have a robust community that will compete and will unlock this market. So there's a series of payloads that we have manifest, and it's going to the South Pole because let's just take something difficult and crank it up another notch. Sure, we're up for it. It was identified, we've got a plan, and we're executing on it. So that's what CLIPS is. Now, this is not a NASA mission. So let me make sure, I'm going to try it again. This is not NASA mission. What this is NASA buying space on Masten Mission 1. Why do I bother to say that twice? Because it's a completely different structure than what perhaps we're used to. NASA is not buying entire manifests. NASA is not dictating what things happen. The program has deliverables that we told them, NASA, Masten told NASA what we are going to deliver when and how to evaluate it. Provided we meet that standard, it's up to us to execute. So yes, there is space available on Masten Mission 1, and we're actively in conversations with a number of different potential payloads for that mission or one of the follow-ons. Exactly which one will be the next one is dependent upon these conversations. Who needs to go where and how much budget and how much risk and all the rest. It is not a, hey, just click a button and there you go. The idea of standards is phenomenal. I will rail against the idea of price per kilogram because that's not the way, that's not necessarily the limiting factor. Actually, right now, I'll tell you on Masten Mission 1, mass is not the thing that is the limiting factor. It is external view, and particularly the bottom of the lander. At the moment, that's the one that is in shorter supply. So we have a number of instruments that are already positioned. I will run out of space for other things to have lunar sight or lunar access from the bottom plate before I run out of mass. So yeah, I get it. Everyone wants to talk, we got to be cheaper, you got to be cheaper, you got to be cheaper. Got it. It is not just a, okay, well, what's the cost per kilogram? So, you know, out of this, where does that leave us? Well, that leaves us with, there are actual missions that are going, there is capacity on those, and now is the time where people who are looking at lunar development have the opportunity to establish which side of the road we're going to drive on when humanity leaves this planet. And I know that sounds a little bit grandiose, but in these next couple of years, while we have these initial missions going, it will be the people and the organizations that are taking advantage now and acting now with that uncertainty that will be able to set the standards that everyone else is going to wind up following. Not because it's mandated by government, but because it becomes the standard. And so I've been, anyone who's heard me speak over the last couple of years, this is not a new thing. I think this is the time where folks can establish, if you want to establish the particular standard, then be the person who's out there getting stuff done. So I'll poke folks and make sure we're asking for questions, but let me offer, while you're thinking of questions, let me offer you this idea about the instruments, the payloads, the applications. The industry and we have a tendency to think about launch is the problem. The cost of launch is the problem, and oh my God, it costs too much to launch anything. Great, accepted, not completely resolved, but let's call it resolved. We're now at a place where launch prices are a bit more predictable. Now comes the other half of that. If you said the problem with satellites is the cost of launch, great. So now there are cheaper launches available, but you can't take advantage of them using the same approach that you would use when you were putting up a bus. I mean, a huge, a huge satellite. If your development framework is, hey, I've got this stuff that we've been maturing since 51 years ago. I can't wait to send it to the moon. Maybe that's going to work. Maybe. But I'm not going to bet on it. I'm going to say the same approach to value engineering that has gone into launch, that has gone into landing, needs to be in instruments. Understand that the framework, if you're thinking about, hey, we might get to the moon 2 times in 100 years, you're going to think about a development framework that is different than if you're thinking about it in terms of what will I do if I had a less polished thing, but I'm sending it twice a year. How does that change the timeline, the cost, the type of data? Like, how do you respond to this new possibility? And I would say, look at the CubeSat revolution. There are some parallels there. I'm not going to tell you that it's going to be necessarily anyone, I don't know if we're quite at bake sale prices to the surface of the moon, but we might be in the not too distant future, at least for smaller elements. So with that, I'm going to take a look here. Looking at questions, Sam is asking, you mentioned 3 companies launching in the coming months. Also mentioned developing standards. How much are you and the other CLIPS companies working together to develop common standards? Thank you, Sam. The common standard is probably not going to come from the launch provider. The thing that I was mentioning about a standard is whoever think of it as a natural monopoly. If you launch a thing and say, okay, I'm now going to have power available on the surface of the moon, the service you are offering, you can offer as a de facto standard. If you say, hey, I'm going to have a fuel depot on the moon, the fuel that you will have, what is the fuel? What is the interface? Right? If I'm selling fuel and I say, great, come to the moon, and when you land, we'll fill you up, but you've got to use the connection that we have on ours because our thing's already there. That will establish some of that standard. So on one hand, that's the de facto standard that will happen as companies are executing. The second piece of your question is, okay, well, why don't you all get together and say, here is the answer and here are the standards? The simple fact of the matter is, and I've spent far too long talking standards, everybody loves the idea of standards until it's not the thing that they want. And so we have discussed it at the industry level across companies to say, yeah, are we at a point now when we need to say, all right, let's lock in on this standard? It is a thing that is being discussed, but it is not a thing that I think there's still too much variation. And I honestly don't know where the value is going to be for lunar access. I'm not sure which one of the various possible futures is going to be the thing. And what I don't want to do is drive a standard that actually is an impediment to the actual application that's going to buy in. So I know it's probably not the nicest of answers. I will answer from Masten's standpoint. We have a standard offer that has power and comm budget and mass budget, and like, you know, we have a standard level of service. And then I'm going to ask you, okay, if you can fit inside of these, great. If you need something different, let me know. We can scale. We've got the ability to turn up any of these different things. It's just engineering. That engineering usually requires additional mass. It requires additional power, like whatever those things are. So we have both here's a reference rate, and then here's the things that we can do to kind of stand on top of that. So let's see. Examples of how instrument design have changed now that launch costs are coming down. So I'll answer first in the sense that I'm not an expert in CubeSat, but what I can tell you is that we have had I'll call it the iPhoneization of satellites. The idea of getting your level of service not through a single item that is checked out and validated bajillion times, but in redundancy and having a large number, and so you're upgrading. That's the idea in the small satellite world. Is these are smaller, they're cheaper, they're developed faster, substantially faster. The iteration time on satellite design in the small end is extraordinarily fast. And why does that matter? Well, because instead of having to design your satellite to use a compute element that's 10 years old, why 10 years old? Well, because 5 years ago you could only spec something that had heritage, and then it takes you 5 years to develop it and build it. And so now you're flying technology that's already 10 years old. If I don't care as much about a single one, I'll put up a batch with the latest thing, and if they don't work, I'll replace them. So that's one example of where you can get more performance, and you're trading that off with, you know, what is your arrival rate of failure? For the moon, what are the things that we're looking at there? So the payloads that are going now tend to be ones that have had some development already kind of going on. And I'll offer several of the payloads that have been selected have already flown terrestrially with us. So you get different approaches, and I'll talk about our friends at Honeybee and the Planet Vac system that they developed and flew. So this is a way to collect regolith. That Planet Vac system was a prototype. They got picked up by STMD to do some development work with us. Used some 3D models. We did some fit ups. They printed another 3D model, got something iterated, flew it, it worked, we're iterating again. It is not the mission driven. It's not like, okay, this has a specific mission that it needs to go on. It's a capability driven approach, which is where Masten has that's the approach that Masten has taken as well. It seems weird to say, well, the mission comes later to a lot of folks in the industry, because we're so used to, all right, the mission gets decided, and then how you execute that mission is defined by that. But if you take a capability driven approach, you say, all right, we have looked at across a range of things, and we see this opportunity. to work across a number of different things, to serve a number of different areas. And then you make it, it becomes a standard, right? Back to the standard question. If you want to acquire a soil sample, Planet Vac is already existing. So that's an example. You know, Honeybee's got several different things they've been developing that fit that sort of model. So, all right, let me take a look here. Thank you for the congratulations from everybody. General tips to come up with a low-cost mission to the moon. What are the drivers of your cost? Is the first question. And so when you say low cost, what do you mean? What are the things that are important? What are the things that you're willing to trade off? So I'll share with you our approach, because this is somewhat of this is in the history now. The GLXP was driving, because it was a dollar amount that was, it was a set dollar amount to get this delivered. The motivation there was to drive to a lowest possible cost per mission. What that did is that drove people to design systems that would utilize rideshare in order to reduce their launch cost. But when you're rideshare, you don't necessarily get where you're going. So you have to now design a system that can take advantage of a low launch price. We took a different approach. We said, when there's going to be real market for the moon, it's going to have more mass requirement. That's why we set our minimum payload mass at 100 kilograms and designed a system that would be a primary payload and be able to control when we go, because whatever the instrument is, or the payload is, we want to be able to get there quickly. So our approach has been not to take our time and get the launch price as low as possible, but instead make it bigger and get there straight away. Now, why does that help us on the cost? Because now I don't need a vehicle that will be designed to hang out and circle around a bunch of times. I can shift that, and my design now is on shorter missions. So those are some of the things, you know, and this is the question of, okay, well, how do you get a low cost mission? Is it the total cost? Is it the cost per kilogram? Is it the certainty? Is it the, like, there's so many different pieces of it. I would love to say, no, I will say, the idea that we're driving to cost right now is a little bit inaccurate. We're still too early, and if this is simply a race to the bottom, this will favor folks that have long-term capital, but then you wind up back in a monopoly sort of situation. So, okay. Next one here, Rodrigo. What's the process to get a payload on a future mission? And is there any allotment for education-based payloads? If you have something that you are ready to fly, the answer is talk to me or a member of the team. Make sure that you're on our roster of potential payloads. You share with us what your requirements are, and I'll be able to share with you where the slots are that we anticipate. So I can tell you right now, Master Mission 1, targeting December 22. If you got something that'll be ready by then, sorry. If you have something to be ready to be part of that payload, great. If not, we can talk about what are the other ones that will follow up. It is a little bit of a chicken and an egg, because you've got, you know, if you want to be the anchor customer, phenomenal. If you want to fly space available, then you got to wait for someone else to be the anchor customer, or we have enough that have enough common requirements that they can work together. So that's what we're doing right now. Essentially, I'll speak it directly. I need to know something about what you're trying to do and the requirements, the desirements and requirements for how you're going to go about doing it. I have to figure out what is the likelihood that a payload is going to have money. I can't bet the company on, oh, well, we're going to raise money. That's great, you're going to raise money. Just keep in mind that I can't bet Masten's viability on an investor that I don't talk to. I can't even bet on an investor I do talk to, much less an investor that I don't talk to. So that is that's one of the trade-offs that will be there. And then I don't know how many folks here are government or related, but I have to have a way to get a contract. So for non-governmental ones, it's easy. For governmental customers, I got to make sure that there is a way for the funding that you have available to actually flow to us. And so those are the things that we kind of look at when we're looking at assessing these potential payloads. And then there's an iteration process. So, okay, what do you got now, and what sort of room do you have for design changes or updates? And just about everybody says, oh, we've got two different things. We've got, you know, the current version that's big and clunky, but it works, and we've got a future version that's going to be much smaller if we just had $25 million of development. So it's like, okay, well, which one are we talking about? And so that will definitely factor in. The question about non-rev, about payloads or students, things like that. Yes, that is a thing that we intend to have some amount that is held out for outreach and experimentation and all the rest of it. We may have some things that are available as we go. That is not the primary function, and it's not going to be the thing that drives the manifest. So it winds up becoming that additional thing off to the side. One of the other problems, challenges, the more payloads you have, the more integration work you have, and the more potential interaction between all the other things. I will tell you that in the CLIPS program, NASA has said, yep, we accept the fact that there will be other payloads. So they accept it. There's standards that we have to hit. So while we're looking at educational payloads, we've really got to make sure that they're on a non-interfering basis. And the question is that the sort of thing to put on to the first one, or is that something that you maybe push out a little bit later on? So couple of questions here. Great. So what is that price? What does it cost? You've already heard my soapbox about not believing in cost per kilogram. The answer to that is $1 million per kilogram, plus or minus, and oftentimes a lot more plus. There's different numbers you'll hear, 1.2, you hear $1 million per kilogram, maybe less than that, maybe more. If you want the first cut rule of thumb, $1 million per kilogram for everything that is necessary to deliver that payload to where you want to go. So if you say, hey, I've got this sensor, but we have to put it into a bracket, and we have to, you know, your power needs are astronomical. Even though your sensor's only 2 kilograms, if the requirements for it in terms of electrical and thermal and bandwidth and yada yada, it may cost, you know, 30 million to take a 3 kilogram thing if the stuff that you need is so high. And this is why I dislike that rule of thumb. And it's really just a question of what are those different requirements. If you've got something that is completely passive and doesn't, like, it's, you want to fly a brick with your name on it, you're more likely to be able to hit some of those lower price points. But the just shaking my head, I would love to be able to just say, hey, here's the pricing, but so far none of the things that we have looked at are that straight. So that gives you an idea in a sense. And so here's the thing, if you, not only us, but if you're talking about getting access from any of the various providers, if you do not care about when or where you go, and you're not consuming any other services, and you're literally a brick with your name on it, the price for that, I would anticipate, will be down, you know, well below $1 million per kilogram within the next couple of years. The location matters. Do you care about where you go? Because not all landing sites are the same, and not all of the, you know, the costs of doing these things are going to be the same. When I look at what's the variation in our cost, it's pretty wide. Like at least a 2 to 2.5x multiplier at my base cost versus some of my stretch costs. And I'm not talking about a new lander design. I'm not talking about the next generation ones or anything else. I'm talking about what is my cost basis going to be based on the current XL1 architecture, current launch capability, pricing, and, you know, what customers are looking for. So anyway, that's a little bit on price, just going to give you some idea. The prices will come down, and if you get to the larger, you know, spaceship, you know, SpaceX's or Starship is going to change a lot of things. If you've got ridiculously cheap launch to LEO, then by extension that helps reduce the cost to getting to the moon. If there's a fully loaded Starship landing on the moon, that's a lot of mass, your 1 kilogram vanity brick is probably going to be even cheaper. I'm not planning to compete on price with SpaceX or any of the other folks, or, you know, Blue Origin or any of the others that are going to carry massive amounts. That's not our model. What we want to do is the bespoke. We have a lander that will serve to the needs, and we can modify that. I can land large stuff. If you're familiar with the Zeus concept, we can do larger things, but I can't do that. I don't have the deep pockets to be able to do that on spec. What landing site would you prefer to go to? Well, for the first piece of this is we've identified for the Masten Mission 1, it's going to be a polar landing. There is a process that we're going through with the CLIPS program. Polar landing is a fun puzzle of light, lines of sight, timing. Yeah, it's all the different things. And sometimes the landing sites that are best for us are not best for the individual payload. So we've got a process that's going on right now to identify what those are going to be. As a decision science guy, I love the fact that our lunar location changes a bit as the calendar rolls on. So if there is, you know, this is not like a delay of a day is a delay of a day. At some point, the delay shifts the window of what the best site will be. And at a certain point, it flips poles. At a certain point, if for whatever reason there is a delay in our Masten Mission 1, the amount of time that the instruments will have on the surface drops below the threshold. And the answer then is, you know what, we're better off to wait and go to the North Pole in, at that point, 4 months, than to go to the South Pole and have a shorter amount of time. So this is a dance that we're going to get.
Sean, hi, this is Mike. I was going to jump in with a couple of questions.
Yeah.
Can you speak a little bit about the customers that you've been talking to, without getting into specifics? What are the broad motivations across those customers? Is it scientific? Is it proving out engineering, TRL acceleration? You know, what are they willing, for the people that have the money that can pay the cost, what are they interested in doing that justifies paying the money?
Yeah. So the suite of instruments we're carrying now from the Science Mission Directorate. So that one's relatively easy. Those are science focused. There are some payloads that are being considered that are space technology. So the way the CLIPS program is set up to pull things from, even though it's in SMD, I believe that the idea is that they will be the clearinghouse for things that might come from HEO or human operations or from Space Technology Mission Directorate. And so you're seeing some of that now. So NASA's interest is broad across science and technology development, and to a certain degree things that are going to relate especially to the human landers to follow. So that is, as usual, there's a bunch of different complementary interests. Beyond that, I will tell you that there are other entities that are looking at how to make sure that the US government is able to extend their view beyond where they are today. So those are things that are relevant. The customer in that case becomes, what's the value proposition? The value proposition is, think of it as protection of the oceans taken into cislunar. And so that is an area that we definitely have interest that seems to be real interest. There are definitely entities that are outside of the US that have interest and a desire to have, the value proposition for them, I think, is more participation and being part of it. Some of those things are technology development, some of those things are science. So what drives it is not, I don't think, the application. It is the connection to some sort of national space policy objective. The conversations that I've had around prospecting, they have all to date been technology plays. I have not successfully had a conversation that gets somebody moving on actual prospecting and grabbing an area for use. There's people thinking that way. My prediction is that there needs to be at least one of these landings that will be successfully completed, and that will then flip someone. I'll express it in the business geek speak. The net present value calculation changes once you take the risk of access off the table or drop it substantially. So, Mike, I don't know if that answers the question, but I wish I could say I have prospectors beating down the door. Believe me, I'm talking to folks, but they're still saying, yeah, the numbers don't close on this.
Right, and that's what I was expecting. So yeah, you in the financial world, as soon as SpaceX's Demo 2 flight successfully delivered 2 astronauts, some people started changing their minds, and so you have to have those risk reduction missions that people can then do the risk calculations, and does it match the returns.
Right. And this is the important thing here is you might think that this is the process that things go through in order to get manifest, right? There's big processes and there's checklists and there's all the rest of it. Once there is existence, there's a whole bunch of folks that are on the other side of that that decided not to act when that solicitation came out. Either they didn't see it or they didn't know about it, or they thought, oh, this is too early stage. And then once you move that, there is demand that exists there that wasn't part of the conversation that all of a sudden wants to be. And it's funny, like I expected that. There's some folks who are like, wow, where's all this interest coming from? Like, duh. Like, of course, there's some people who decide not to apply to a program, but they've got stuff they want to do. And once you show them you're real, they show up.
Yes. I've got one other question, then I want to jump back and let everybody else go on the rest of them. Can you talk a little bit about the surviving the lunar night work that Masten is working on?
Yes. So 2 threads to that. One, we know that there are payloads that are going to want to survive the lunar night, and making sure that we've got options that are available. 2, we have a program that we've been doing that is designed to provide a non-electric, non-nuclear solution. So it's a metal oxide warming system that is designed for surviving the lunar night. So that's, I think I mentioned back at the beginning, kind of tech development. That's one of those ones that's in tech development. We had a phase 1, now we're on a phase 2 SBIR. That technology is being considered elsewhere, and where it can help provide value to payloads, allow us to get more demonstration or get more science out of an instrument by including that along with it. So that's
so for the system that you're working on for providing heat. Do you have a general range for what temperature the vehicle, the lander, would be getting down to, even with providing it a source of heat?
I'm sure that PI will have an answer for you on that. No, I don't have one off the top of my head.
I'm assuming it's still really cold.
Yeah, I mean, there's some really weird and interesting things about the moon. Like, the moon is tougher than deep space in some ways. Mm-hmm. Like there's still a lot of really cool science that I'm still learning about the moon. My main focus is on trying to make sure we have the business strategy necessary to keep us alive long enough for that to happen. So excellent. There's a question here about landing pads. Yes. We are doing some work in landing pads as well. You may have noticed we have one of our chief engineer, Matt Coons, was awarded a NIAC grant to study the idea of formulating landing pads as you're landing. We're also doing some work with the plume impingement community and Phil Metzger at UCF about improving the modeling by doing some real world testing and trying to make sure that the model will fit together. Plus flying some payloads to help characterize that. The wide variation, my question is, which future are we talking about? In one of the possible futures, there are a few key locations, and the timing of access to those few key locations is not as critical. That would probably favor a built infrastructure, landing pad, structure where you're going to be going to the same place over and over again. If another possible future is wildcatting on the moon, that it's not about large things, it's about getting to a number of different places and being able to quickly get to a location. The assessment comes back, hey, there might be something here, and you're sending a survey team there within months. That will probably be a lot of smaller landers because you'll have less interaction with the surface. So there's a bunch of different potential solutions there. It's a big deal. Moon dirt is sharp. Depending upon how you're interacting with the surface, you're kicking stuff up into lunar orbit. And so it's all the trade-offs there of, do we try to understand it and mitigate it, or do we, I don't mean Masten, I mean industry, do we just say, screw it, whatever it is up there, and we will cover that risk on the spacecraft, or do we establish something that says, you can't make the lunar orbit inhospitable to other spacecraft? These are big questions that have yet to be answered. The good news is that there is research that has gotten a lot of focus. Actually, this is kind of way back in the day. One of the first customers that I met when we were, Michael was introducing me to the team, was a team that was doing some plume impingement work. And a decade later, that's the hot topic, which to that staying alive thing, the adage you may have heard is, the market can stay irrational longer than you can stay liquid. Knowing that a future is going to come and knowing with any sort of certainty when that future is going to come is tough. And I've watched plenty of other companies come in, bet the farm on the future is arriving in 12 months. And if the future hasn't arrived in 12 months, they're up the creek. So we've instead focused on who are the people, whatever the future is, who are the people who are going to be involved next year? Who are the players, and how do we make sure that we're serving not just the current players, but also prognosticating, okay, yep, I can see these folks are going to be involved. I want to make sure I'm working with them. Probably getting close to the end of the time here.
Yeah, we got time for one more, Sean. How about from Cohen Hyde? What is the most interesting payload someone has approached you with?
There are a lot of interesting ones. There's been a lot of really cool technologies to solve problems that I wasn't even thinking about, right? Like, oh, yeah, that would be getting power into the permanently shaded regions, and like, there's a lot of cool technology that I don't know if that counts as it's very interesting because there's people that have solutions to problems that I'm not necessarily thinking about those problems. There have been a number that are, I'll say, on the crazy side, and I definitely love to talk a little bit of crazy. There are some really big ones that are really interesting, and I think is probably where, if you're talking about taking a single payload that's going to be, medium rover size, you're talking 600 kilograms. Those are, I think, really interesting, especially if those payloads have built into them the idea that they're going to continue to be there and operate because then there may be interest in bringing some additional supplies to them or returning things that if you're looking at something that's not just a deliver it and be done, that's the stuff that I really have interest in. I'm looking at it's one thing to carry a passenger down to Disney so they can go to Disney World, Orlando to go to Disney World, but what I'm more interested in is the business customer that's going to be going twice a week back and forth. That's the real interesting one that I'm still searching for, and I'm hoping one of you will be that that customer. So awesome. Well, look, I really appreciate the invitation to talk to you about what it is we're doing. If you would like to be one of the partners that we work with, please reach out to me or any member of the team, and we'd love to figure out how your vision of the lunar future can see manifestation through the support that Masten can provide. So
Thank you so much, Sean. We really appreciate your time, and we'll see you on the surface of the moon in about 2 years, it sounds like.
I'm working on it.
All right, thanks a lot. Have a great day.